Hello, Assalamu alaikum. This is the video about a project which was done by me in this semester as a final semester project in the course named Microcontrollers and Embedded Systems. The name of the project is a line follower robot, which is done by me and my group member with roll numbers 221682 and 221748. This was done under the supervision of the supervisors, Engineer Umar Farooq and Engineer Sadia Said, and under the Department of Mechatronics Engineering, Air University, Islamabad. This table includes the team member's name, the roles, the word counts, and their signatures, along with the color codes provided below. So the index will include the proposals, the initial feasibilities, the specification of deliverables, the team roles and details, and a Gantt chart along with the estimated budget in the chapter 1, which is the preliminaries. So chapter 2 is the project conception, which includes the introduction, the list of features and operation specifications of our project, the project development process, the basic block diagram of the whole system and subcomponents in the draw IO, or you can use any similar tool, and the literature review of each component. The chapter number 3 will include the mechanical design. The mechanical selection, the mechanical design actually includes the mechanism selection along with actuators with specification and the datasheet. The chapter number 4 is the software and firmware design. The software and firmware design will include the controller selection with features, the software design details and user requirements, the state machine system flow diagrams, and a detailed block diagram. The chapter 5 will include the simulations and final integrations. The integration and testing all hardware and software components separately. The simulations, which include the Proteus with state machines, the simulation PCB and 3D view. Chapter number 6 will include the system test phase. The 6.1 is final testing. 6.2 is something, the things that are questionable and getting burned again and again, which was kind of hectic procedure. The chapter 6.3 is project actual pictures. Chapter 7 is project management, in which everybody wrote about how they executed their role. They commented individually about the success and failure of the project, the final bill of materials, and the paragraph about project budget allocation. The word count and risk management, which we learned, is given in that chapter. The chapter number 8 is feedback for project and course. This also includes the YouTube video links along with the explanation video link, which is being recorded right now, the LinkedIn profile links individually, the YouTube video links of the project working condition individually, and the GitHub individual links. So the chapter number 1 begins with a proposal. So objective was to construct a line follow robot according to the guidelines provided by the line provided. The line follow robot is an autonomous robot which follows a line until the line exists. So the purpose of this the project was to make a line follow robot which is not only a line follow robot, but it can also sense obstacles and avoid them. So the initial feasibility was we had to learn the mechanism of a line follow robot, like how does a line follow robot work. So we had to learn that. So for that purpose we understood the turtle robot simulation and Proteus, and through software implementations with a basic design using 3 IR sensors and 2 motors and an LCD, which initially we were going to use 3 IR sensors, but then we decided to use an IR sensor array. We developed a basic straight line test capable robot and tested it on straight line, and that was success. The specifications where we had to use an Atmel based controller, we had to use L298 motor drivers, we had to use some battery, a micro SD card module, an IR ultrasonic and color sensor, and embedded side we must use the input output, the timer, interrupts, which was we had to use an interrupt button, and PWM in a REHBER robot. The brain of a robot should send data wirelessly to a remote computer using a wireless module. This wireless module can be a Bluetooth module or an ESP32 module. So a report describing our effort, a block diagram with pin algorithm and state machine, and the schematics, the PCB design, the bill of materials, and everything is given in this report, which will be submitted on GCR soon. So the team role is assigned here. So 682 was responsible for the report and the software, while me 748 was responsible for the hardware and the code. The milestone Gantt chart begins with the creation of PCB design on the software phase, which was done on 17th March of 2024. So the hardware testing and straight line test was done on 26th March 2024. The soldering of components and component selections and connections to the PCB was done on 19th of April 2024. The PCB testing was also done on 19th April. The sensor interfacing was done on 20th of April and the robot testing was done on 21st of April. The final project's checking was done on 22nd of April 2024 and the completed project report was submitted on 6th of May 2024. So the project started on 17th March and is to be concluded on 6th May while we're still working on that project as we're making a video about it. So the estimated budget was along about 15,000 rupees, which actually extended up to 20,000 PKR. The chapter 2 begins as the project conception. So the line follower robot is a robot that can follow a path. The path could be a black line or a white line. So we had to use an eye sensor array. Along with that, we had to use an ultrasonic sensor for avoiding obstacles and a color sensor along with that ultrasonic sensor so it can detect the color of the obstacles. So the features is that we had to use an eye sensor array which has 5 eye sensor and it can detect angles on the path such as 90-degree turn or a 45-degree and also curved turns. The project should also be able to avoid any obstacles using an ultrasonic sensor. The encoders are used to determine the speed of the motors. We have two motors for two wheels mounted, and we have a SD card and ESP32 to create a data log and control the robot via Bluetooth and Wi-Fi connectivity. And the SD card writes the real-time data from the voltage and current sensors, while the ESP32 sends that real-time data to cloud using ThinkSpeak library. The components include the ATmega 2560 with its pin configuration given, the ESP32, the OLED display, the SD card module, the motor driver, the IR sensors, the robot chassis, the ultrasonic sensor, and the N20 motors, along with the jumper wires, the header pins, the on-off buttons, and the batteries. The project development process. So we had to start by understanding the process of making of the robot. So the idea of the project was well defined at first by reading books, actually journals and magazines were really helpful, and websites. The logic derived from the intelligence of the robot. It is programmed and the program is burnt into the Arduino using the Arduino IDE software. The accuracy and the viability of the program and electronic component is tested in the simulation software process. After this successful simulation, it is implemented on hardware. And for the hardware, we have designed our PCB board to keep the robot more professional and fictional. Finally, the system is tested and encounter error is omitted. So the initial block diagram is provided here. So the Arduino Mega is connected to the SD card, the ESP32, the area sensor array, the LCD panel, the main power supply, the L290 motor driver, the right motor, left motor, the encoder right and left, and the ultrasonic sensor. So after the basic block diagram, what begins is a literature review of each component. This will explain the working of each component. So first of all, we have the ultrasonic sensor. So ultrasonic sensor actually works is that it generates or sends an ultrasound energy. The ultrasonic sensor sends a high pulse and then a low pulse in a continuous manner. Once these signals hit an obstacle, the signals reflect back and they're received by ultrasonic sensors. The time taken by the signals to return is used to calculate the distance between the sensors and the obstacles. The closer the obstacle is to the sensor, the quicker these signals return. The pin configuration for this is given. The Arduino is and its detail and the pins it has are given here. The pin configuration is given. The robot chassis details are given here. The eye sensor and the working of eye sensor on a single eye sensor is described here in a really easy manner. After that comes an L298 motor driver, an N20 gear motor, and why we use an N20 gear motor is it's really fast and really compatible and it's really easy to use motor along with its small in size. The encoder and its working, how it works, is provided. It is really easy to understand just by looking at the diagram. The SD card module is a bit of a complexity, but the SD card module is really easy to use as it has well defined pin names and it has a built-in 3.3 volt voltage regulator, which we can directly connect SD card to any power supply and it will convert it to 3.3 volts, which is necessary for the working of an SD card module. The OLED display is connected to both I2C and SPI communication methods, but we had connected it to the I2C pins. It is really easy to use and its pin configuration is also given. Then comes the current and voltage sensor. The current sensor works on the Hall effect principle, and the voltage sensor just works by bridging the path, just by putting the positive and the negative wires in the sensor, and it gives an output. As we were also new to the project, so we had to do some research and take help from certain websites with a link provided here. So the chapter number 3 was the mechanical design. So mechanical design includes the mechanism selection and platform design. So the robot chassis is easy to set up. So let's create a mobile robotics platform in a short time. So the robot chassis was really easy method, but we were thinking of placing PCB on the robot chassis, but in the end, what we did was that we made holes in the PCB and made it a chassis for the robot. These were the initial components that we had bought for the straight line test, and the picture below is of the basic testing for a robot on a straight line test. The video for this is uploaded on my YouTube channel, which I will also show it to you guys. This was the robot's initial phase. It was the birth of the blindfold robot actually. So actuators and their specifications along with the datasheet is given here. So chapter 4 includes the software and the firmware design. The controller we used is an ATmega 2560, which is a main microcontroller. It is a basically we're using AVR based microcontroller. The parameters are given here in the report. The advantages and disadvantages are also given. Advantages: one advantage is low power consumption with fast startup, and disadvantage is that naturally lacks incremental performance compared to high bit microcontrollers. So for these basic small projects, an Arduino Mega 2560 is more than enough. Even we could have used an Arduino Uno, but due to lack of pins, we had to use an Arduino Mega 2560. Their specification is given here. The software details and the user requirements are given here. The components named ultrasonic sensor, the SD card module, IR sensors, L298 motor drivers, OLED display motors, current voltage sensors, etc. are given. The outputs were the left-right motors, the SD card, and the OLED display. The state machine and the flow diagram are described here. So first, this will describe the next stage when a robot is stopped. The next state is forward and goes to the forward state. Now the forward has two options, left and right. If the input is left or right, it will declare its path. So when it is right, it will go to the right, and when it's left, it will go to the left. So on left or right, it is two options again. Either it can go forward, either it can go to the right or to the left. And on the left side, it can go to the stop, and from on stop, it can go to the right. So this is the basic flow diagram and of the state machine. This is the detailed block diagram of our project. So this includes our ATmega 2560 Arduino Mega actually. The ESP32 is connected with the TX and RX pins. The SD card module is connected with the SPI pins, and the OLED displays connect with the I2C pins. The SCL and SDA being the main pins. The IR sensors is connected to the analog inputs along with the voltage and the current sensors. The interrupt button is actually connected on the interrupt, and the main button is for the on and off of the robot. The motor driver is connected to two motors, the motors being connected to the encoders which send data to the Arduino, and the motor is connected to the tire 1 and tire 2, which are responsible for rolling the tires. So the chapter 5 are the simulation and final design integrations. So first of all, we had to check each component individually on the software. So as I said, we had to study the turtle robot simulation. So this is the simulation of the turtle robot. So then we had to test the ultrasonic sensors. This was a testing of ultrasonic sensor. This is the code for the testing of ultrasonic sensor. This was the testing of infrared sensor along with the motor driver. This is the code for that, and the complete line following robot simulation was provided here. The Arduino IDE code to test the line fall simulation is given here. The compiled Arduino code for this whole project is given here. This code will also be provided in the link in the description, which will be available on my GitHub profile. You can download the code from there. The making and the testing phase. It includes the block diagram, which I already explained. It includes the Proteus simulation. I will also explain the Proteus. It also includes the simulation print, the PCB print, the PCB 3D design, the components and the real pictures. So you can see this small PCB. This is actually for the ultrasonic sensor and the color sensor, which is provided here. So let me explain a bit of a PCB for you. These are the pins for the motors. This is power input pins. This is analog inputs. This is the PWM pins. This is the SPI, and this is the I2C pins. These pins are for the OLED display. These pins are for the IR sensors. These are headers for the SD card. These are headers for the voltage and the current sensor, and this header is for the buck converter. These are for the color sensors and the ultrasonic sensors. The PCB is really easy, simple to use. The design of the PCB is also available on my GitHub profile. The link will be provided in the description along with the code. These are some real-time pictures. So this was the initial phase of the birth of REHBER PCB. This is what I told, that we actually made the PCB a chassis. So this was the start of REHBER. So this was near to completion phases. It was missing actually the installation, which we'll add later. For sending of data to cloud, this is the sending of data to cloud. This graph actually is it voltage and current values data on web server using ESP32 using ThinkSpeak libraries. The comment individual of failure of a project. Sorry, the comment individually about failure and success of a project. So this project was success. The both group members agree. The bill of materials is provided. So the bill of material was approximately 20,000 rupees. The word counts and the color codes are given. The failure and the solution are also provided. Actually, one of the failure was the PCB etching was taking a lot of time and missed a lot of races, so we had to solder them. Another issue was with the libraries in Arduino IDE, which we learned and fixed that issue. So this chapter 8 will include the YouTube video links. This video link will be provided here. LinkedIn profile links, which are provided. Uh, LinkedIn profile links are provided. The YouTube video links, the working project video links are provided here, which include the working of the project, and the GitHub profile links are also given here. So now I will show you some things which are necessary for you guys to see. So first of all, let's see the code. This is the Arduino IDE code. This is available on my GitHub profile. This includes the basic libraries which are necessary to initialize the components. And the basic initializations to run the code are also done here. This is the simple logic for a line follow robot. This is the logic for the OLED display. This is for the display of different colors detected by the ultrasonic and the color sensor onto the OLED display. And these were the digital write, which were actually calling stop function of the motors. And this actually is the reach. This will be written on the OLED display when the robot reaches its destination. So the ESP code is really simple, but you guys have to understand some things for that. So this will include your ID, your password. This is my hotspot, so I changed the password. You cannot use this. So this ThinkSpeak address, you had to put the website link here. What you have to do is you do not have to put these two here. You have to put your own here links here, which I will show you how to put. So first of all, you had to go to your ThinkSpeak account. You have to go to your private view, in which you had to create your own channel. So as you can see, this will give you graphs. I had done 43 entries. Last entry was done 28 days ago. So you have to go to your channel settings. This will give you a channel ID. So you had to copy, or you can also go to the API keys uh, or sharing. Just go to your API keys. The channel ID is provided above. Copy this channel ID, and you can easily just paste it into the channel ID section. And in API key, you have to paste this here. So every person has a different API key, so you just have to paste here, and your ESP32 code will be ready to work. This code is also provided on the GitHub account. So first of all, I will show you the post about this light follow robot on my LinkedIn profile. So this link all includes the GitHub profile link, the YouTube straight line test link, the PCB test link, and the working video link will be provided here. This includes some pictures. This was the final picture of a robot. This is the straight line test phase of the robot, and these were the input and output. The output values on the cloud of the ThinkSpeak, and this was the voltage and current values. This is showing the OLED display in uh, showing real time values. So the LinkedIn profile should also my LinkedIn profile also includes uh, different projects, including the semester's mid project, which was making DIY Arduino board, which is also provided here, and the the GitHub is provided here. Actually, when you will click to my GitHub account, you will find here is this complex line following robot. So you have to click here, and once you have clicked here, you can see this is the Proteus file. This is the project report file, so you can easily understand it. This is the ESP32 code, and code will enable and disable this, enable A and enable B, which is the Arduino ID code. To download this file, just click on the code and download zip, so you can easily download it. So if you want to upload files and you do not know how to upload files, just click on the repositories. You have these are my projects. You have to go for uploading you have to click on new. You just have to name the project. You can do anything. After you have named your project, you have to create a repository, and it will give you an option to upload existing files. So you can either upload new file or existing file. So if you already have files on your laptop or your computers or your mobile phones, just click on upload existing files, and you can easily upload your existing files. So next thing I will show you is that the videos of my straight line test. So this was the PCB test.
challenge.
करीब कर दो करने नीचे से
माशाअल्लाह
रुकना चाहिए यहाँ
नाइस अब्दुल्ला challenge.
So this was the basic straight line test, and the PCB test is also available here. So these were some of the things which I had to share with you guys regarding this project. So with this, I can conclude my video. If you have any query about this project or anything, you can ask me in the comment section below. All the files and links to my profiles will be provided in the description. The files will be in my GitHub account. Will link in the description, and my LinkedIn profiles link will also be in the description. And thank you for bearing me. Allah Hafiz. Goodbye.